Yep. Hello, everyone. Welcome to another session on AWS Builder Skill Sprint from AWS User Group Madurai. So this month we are going to talk about serverless the whole month, and we have an serverless hero joining us today to explain and serverless app how they built it and how people are using it, like from KonfHub. So today I have Srushith from KonfHub to present us and session on the serverless app which they have built. So, Shushit, over to you.
Thank you so much, Gopalan. So thank you for having me here as a part of the serverless month. Couldn't be happier for a better month to join the efforts that you guys are putting in. A very warm welcome to everybody who's joining us. So today's topic is building an AI-powered photo gallery with serverless, obviously, and event-driven magic. So let's get started. So first of all, who am I? I'm Srushith Repakula. I'm the head of engineering at KonfHub, and I'm also an AWS Serverless Hero. I also organize a couple of meetup groups. One is the AWS User Group Tirupati, and the co-organizer of Serverless Group, which is a serverless-specific group here in Bangalore. So that's a very brief introduction about me. So, what is it that we're going to try and cover today? We're going to talk about what are we trying to build, how did we build it, the architecture, of course, under the hood, the AI sorcery, optimization and performance, scalability and privacy, which is very important, especially when you are dealing with user images, the download challenge, and the key takeaways from the session. So I hope you all have something interesting to learn and take away from this session. So let's get started. First of all, what is it that we are trying to build? So we are trying to build an intelligent photo gallery app that can automatically, you can think of it as your Google Photos gallery, where you have a bunch of images that you upload and you can share it with people, right? And what is the intelligence part here is automatically I as a user can search for images where I am present using my face. That is the AI capability that we are going to build today. And the most important thing is you don't need to know about AI or ML stuff. And just between us, I don't know anything either about AI or ML. I'm still a newbie just getting started. So don't worry, stay with me. AWS is here for us to help us build something cool without even having to understand the nitty-gritty details about AI and ML. Okay, so what we're going to build is an automatically compressed uploaded images for better performance, detect and index faces using AI, which the service that we're going to use is Amazon Rekognition. Let the users search by face, the use case that I just talked about, without manually tagging them. So whenever we are uploading, we as a user, we don't have to tell that this image has so and so people in it. And when that person comes and searches, it'll come. So no manual tagging, all of that is automated. And I'll show you how. And then scale effortlessly without managing any servers. I mean, that's the whole point, right? It's completely serverless and event driven. So if you guys can scan the QR code that is on the that is displayed, I'll show you a live example of what we had built. So this is an application that we have built from KonfHub, and this is the gallery of an event that happened a couple of days back on 8th and 9th of July. So it's an actual app running on production, and this is an actual customer of ours who is using the application. So I'm giving you real world examples, right? So if you see here, so what happens is, as I told you, it's a very simple application where I, as an event organizer, can upload images that I want to share with all of my participants, and they can perform a face search, right? So this is how it is, very simple and straightforward. So all of this is rendered from S3. I'll be talking about what are the various optimization techniques that we have taken into consideration. So this is an actual event, right? Now, one is the ability to share the images with everybody in the most efficient and a performant manner. So this is that. Now, let me show you another example. So this is another one. This is Serverless Days Bangalore event that we did in 2024. So as you can see, there are a bunch of images that have been uploaded by the organizer, and they have been categorized as well. As you can see, there are speakers, who are on the list of speakers, and you can basically see this. And then there is booths as well. So there are categories available, right? Now, as an end user, I was a part of this event. Now, I know there are hundreds of images over here, but as a user, what is it that I am more interested in? I am more interested in finding out the images that I am a part of, right? So that is where the face search feature comes into picture. So, so as you can see here, I have clicked on the face search. I can either capture a photo or upload a photo. I'm just going to go ahead and capture and search. And as you can see here, the images, all of the images that I am a part of have been filtered. And all of this is happening dynamically. As you can see, this is all me. And even in an image that has so many people, the application was able to identify me, right? So all of these are just my images. Out of the hundreds of images that the organizer has uploaded, I am able to find out the images that I am a part of, and I can easily download them or use them and do whatever with it, right? So this is exactly what we are going to build today, and I hope you are excited to learn what are the various things that went behind the scenes into building something like this. And a small secret before I get inside, it's not difficult, it's very easy, and you will see why. So the very first question, I showed you what we built. Now the very first question is, how did we build it? So the architecture, this is the architecture diagram. Of course, it is a slightly minified version of what is the original one, but you get the crux of it. All the important components are available here. Okay, so we have the users using the application, and they will be logged in using Amazon Cognito, which will be used for authentication and authorization. And then what happens is, there are two user personas in this particular application. One is the organizer who is uploading the images that he or she wants to share it with the participants, and then the other user persona is the user who is consuming it, the one example that we just saw sorry. So let me talk about the organizer side of things first. So as an organizer, we have a dashboard where you can configure this gallery and upload the images, right? So what happens is, this is all from the organizer side of things. Okay, what happens when the image is uploaded into the application? So of course the user is authenticated and authorized, and then they upload an image. Now, how do they upload an image? They upload obviously to S3. So what happens is, a Lambda function is called, and we check the permissions of the user, and we return a pre-signed URL, a pre-signed upload URL, which is returned from the Lambda function to the user to be able to upload the images to S3. Okay, and once the images are uploaded to S3, a confirmation is given on to the end user, to the organizer on the application, and the UI on the dashboard side, which of course I have not shown you guys, will trigger an API calling the Lambda function using API gateway, and tell us that these are the list of images, the S3 URLs that the organizer has uploaded to this particular app. And that comes here. And what we do is, the very first thing is, we store the original URL. When I say original URL, I mean the uncompressed original file image that the organizer has uploaded. We have already stored it in S3 directly. The UI has done that. And now we store it in the backend as well, in the database. And once that is done, we trigger and we push a message to SQSQ, and that triggers another Lambda function. So what does this queue? What is the use of this queue? All right, it is basically to handle the scalability factor. As I told you, it's an organizer who is trying to upload images, and there can be hundreds of images, if not thousands, and we have observed thousands as well, that the organizers upload. So you need to make sure that as you all might already be aware of, a Lambda function can only run for 15 minutes, right? And a Lambda function that is attached to an API gateway, because the UI is using it, although the Lambda function can run for 15 minutes, an API will time out within 30 seconds. Right? So we want to do a bunch of things which cannot be done by this primary Lambda function. So we have decoupled all our background processing stuff into another Lambda function, which is triggered by a message from SQS. So this Lambda function, which is accepting that the organizer has uploaded images, is pushing a message into SQS queue, which will trigger the Lambda function. So as I told you, the SQS queues here help in decoupling. And apart from that, it also helps in making sure that my downstream services, here it's still a Lambda function, but if in case I'm using any third-party services, it's not overwhelmed, and I'm controlling how many instances of the Lambda function come up. So I have a control over the scalability of how this piece of the application is working. And with SQS, you get the ability to retry if at all whatever something happens for this Lambda function, or it timed out, or it errored out, or whatever. We have inbuilt retry capabilities with S3 that helps in building the resiliency into the application. So this the secondary Lambda function, what it does is it is used for compressing and indexing the images. So compressing. So why do we compress the images? If you all, I mean, I'm sure all of you would know, even if you take a photo in your phone these days, a normal phone itself, a normal image that you would capture would come down to a few MBs, right? Easily 3 4 MB, the minimum. And we are talking about a use case where organizers are using the images that have been captured in DSLR cameras, right? So the average size of these images range anyway from 10 to 20 MB each single image, right? And now there are hundreds of images. There's no problem in uploading. The organizer is uploading, the upload happens in parallel and all those things. But as an end user, when you're trying to load the gallery app, you don't want the images of size 10 15 MB each of them to load on your application, right? First of all, it would take a lot of bandwidth, either your Wi-Fi or your mobile network. It's going to consume a lot of bandwidth, right? And the second one is it's going to take time. These are heavy images, right? And having hundreds of them will only slow down the user experience for the end user. So therefore we compress it, right? I'll be talking a little bit about that in the upcoming slides. And then the next part is we index the images. Excuse me. So what is this indexing of images? Bear with me. I will be talking about in detail in just a minute. So those indexed images are stored in Amazon Rekognition. Amazon Rekognition, as I told you, is the AWS service that we're using. And this compressed image URL is stored back into the database. So now my database contains the original URL and the compressed URL as well. Now, depending on my use case and my scenario, my application can decide whether it wants to use the original image or the compressed image. A simple example: when the user is loading all the images, right, on the landing page, we would still render the compressed one because we want it to be very quick. We want the experience to be very smooth, like I showed you at the beginning, right? Whereas if someone wants to download, we would probably want to give them an option to download the original image, especially the ones that I'm a part of. I would want to get the highest of quality image, right? So depending on the use case and scenario, we wanted to change which URL we want to use. That's why we are storing both the original as well as the compressed URL. Now, I hope you all understood the various components of the architecture. We will, of course, be talking in depth about Amazon Rekognition indexing part as well. So this is the organizer facing side of things when an image is uploaded into the application. Now, under the hood, what is the crux or the hero of our application? It is Amazon Rekognition. So what is Amazon Rekognition? It is a service. It's an AWS service, an AI service that makes it easy to analyze images and videos using deep learning. And the best part, no ML experience required. As I told you at the beginning, I do not have any ML experience, and I was able to build this entire application. It's so very easy to use. So here are a bunch of features of Amazon Rekognition, where uh, it has some 8 to 10 features, if I'm not wrong. I've listed the more prominent ones here. The first one is label detection. You upload an image, and Rekognition will help you identify objects, scenes, activities in the image, etc. A simple example is if you go to the AWS console and go to the Rekognition service, you can play this. You can play around with this. What happens is you will be there's an image already available. It will tell you that okay, there's a building here, there's a person here, there are cars here, and stuff like that. So that is what is label detection. Then you have image properties, analyze brightness, sharpness, contrast of images. This is about the properties of a particular image. You can use Rekognition for you to be able to capture this information or gather this information about the image. Then you have image moderation, which is basically used to flag inappropriate or unsafe content in an image. Then we have facial analysis, detects the facial attributes like age, gender, emotions, like for example, if the user is happy, the user is sad, etc. Right? And then you have face comparison, which is basically a feature that helps you compare between, gives you the comparison result or the confidence of comparison between two images. You upload two images and it will tell you whether they match or not. Then you have face liveness. This is new, if I'm not wrong. Determines if a face in the image is from a live person, or it is spoofed, or the image is live or not. So this helps with that. As I said, Amazon Rekognition is the hero of our application. And then we have the index phase. So index phase is an API that helps you detect faces in an image and stores these facial features in a face collection for further matching and search, right? So if you can observe the image on the right hand side, so if you upload an image to Amazon Rekognition, what it will do is it will try and identify the faces in the image and stores them in a collection. So what is a collection? I'll get to that in a minute. So if you can see here, this is the image with 4 people identified, and this is the Rekognition. It identifies the facial features, and each face is assigned something called as a face ID, and that face ID is what is actually stored in the collection. Okay. So what is a collection? So you can think of it as a searchable database of faces, right? It is like your Google Drive, where you are uploading a bunch of photos, where you can use it to, and you can leverage it to search, right? Each face stored has a unique face ID, as I already talked about, and it can also have an optional parameter called as external image ID. There's a reason why I have mentioned here. I will be talking about this when we cover the optimization and performance part of the presentation. And then it also gives you in the image where exactly is the user. There's a bounding box, right? Here you can see this. This is the bounding box, right? It can tell you the coordinates of the face in the image. So if at all you want to plot that this is the face identified in this image, you can do that. So essentially what is happening under the hood, so whenever an image is uploaded or used for indexing in Amazon Rekognition, it'll detect the faces, generate unique face IDs, and store the facial data in a collection. So this is, if you have to take one slide of a summary of what has happened, this is what is happening with the Rekognition. Okay. What does this help us? This helps us with searching across images that have been uploaded. So basically you have a collection or a database of images. Now, if you remember, I had uploaded my image and it was able to pick up all the images where I was a part of. So this is what is happening under the hood. So the indexing part helps us to search for images in the collection, retrieve matching photos instantly, as we saw, do all of this with no manual tagging or sorting. As I told you, the application from the organizer side of thing, all they are doing is uploading images, nothing apart from that. And this identification of the faces, everything is happening automatic behind the scenes. So the next main part is the search image by face. So we've been talking about indexing. So you now have the database. Now you will have to have the capability to be able to search the images in that database, or rather collection, technically, right? So what is it that we use? We use a search image by face. So it is an API that compares a new face or a face with the existing faces that is available in the collection, and returns all the images that are matching. Now, here what we can do is, while calling the Rekognition's search image by face API, you are telling that this is the input image, which you, if you remember, my image which I captured live, and it is searching against a collection of images for my gallery app, and I have specified a confidence score. So you as a developer can decide and configure that confidence score, and we have configured, if I'm not wrong, 70 or 75%. So what that means is, it is telling Rekognition that get me all the images where this face is present with at least 75% as the confidence score. So that is exactly what is happening with this search image by face attribute. So if I have to summarize or define a collection to search within, can specify the threshold. So you can put 90% confidence, 100%, 70%, up to your use case. And the response includes the face ID, external image ID, similarity score, and the bounding box. So this confidence is there, but if you still want to, in your application layer, decide if you still want to filter out, you can still do that. And the bounding box, as I said, you can leverage that to draw the draw the box in the image if you want to do that. So again, I have mentioned external image ID. I'll come to what is there. Yeah. So optimization and performance. So it is very important because there are end users involved and potentially users across the globe who are using the application. So it is very important that the application is both optimized and performant. Right. So what are the various measures that we have taken into consideration while building this application? The first one is on-the-fly image compression. If you guys remember the architecture diagram, the moment an image is uploaded into the application, a message is pushed into SQSQ, it triggers a Lambda function to compress the image. So what we were able to achieve is reduce the image size by almost 80% with the compression algorithm that we have used. And sometimes I have observed the example that I have actually given you, that Indonesia event that happened a few days back. There were some images where we were able to achieve 90% compression with no loss in quality. So it was, and what is the advantage? As you can see, as you might have tried out scanning the QR code, the images are loading blazing fast, right? So what we do is every uploaded image is compressed using a Lambda function to reduce the size for blazing fast loading speeds, and save the bandwidth and storage costs as well, right? Because now you have a compressed image. If needed, we can actually get rid of, chuck the original image, which is 15 MB in size, and keep an image which is probably 1 MB or even in KBs, right? And nobody even would know it, right? Because of the compression. So that helps in both bandwidth and storage costs. CloudFront for global caching. Now, it's an image sharing application, right? Potentially hundreds of images are there, thousands sometimes, and hundreds of users are going to use it. Now, to make sure it is very fast in terms of loading, one is we have reduced the size, and the second thing is we are caching it using CloudFront, right? So what happens is all the images that are rendering from the application are being rendered from CloudFront cache. So what happens is we are further improving the performance, because let's say I load the application for the first time and someone else in my region loads it, it'll be even more faster for them because it is getting rendered from the cache that's available in the edge location. So this helps in reducing the latency even further. Even though we have already compressed the images, it'll improve further. It also helps in resilience and scalability. And one more thing that I forgot to add is it also helps in cost factor here again, because you are trying to fetch it from cache, not exactly from the S3 bucket, right? Now, you might have observed that I have at least a couple of times I talked about external image ID. Now, why I stressed it about and why I am talking about this as a part of our optimization performance is we kind of build a little bit of a jugaad, if you may, if you want to call it, of how to make sure that the performance of search is still very good with very minimal calls to the database. So think about it. How would we generally do it? We have a bunch of image URLs in the database, right? And every image has been indexed, and there is a face ID that is generated for every face that is in the image, right? What would we generally do? We would say, okay, there's this image 123. There are three or two faces in it, face ID 1 and face ID 2. What you could do, you can simply store in the database saying image 123, there are two face IDs in it, face 1 and face 2. Now, when an image search happens, what we can do is we get the face ID, matching face ID. You can reverse look up and get all the images that have this face ID in it, right? But what we did was we said, I don't want to do so many database calls because I want to reduce cost. I want to make it very much more performant. So what we did was there's something called as an external image ID, which is like a metadata of sorts where you can store whatever you want, of course, with character limitations. And the type of characters also, there are some limitations that you'll have to look up in the documentation. So what we did was we started, whenever the indexing happens, right? At that time, we are passing this external image ID, which holds the original image URL, right? So what happens is essentially, instead of having image to face mapping, face ID mapping, we now have a face ID to an original image mapping available. So basically, whenever we get the face ID, we will know all the images where this face ID is present in the search API itself. This helped us in avoiding a separate DB lookup or reverse mapping, helping us in improving the performance of our search and reducing the number of API calls we make to the database. So other various optimizations that we did as a part of the application. The first one is, as you may know, AWS Lambda comes with a couple of instruction sets, the architecture. One is ARM64, which is not the default, if I'm not wrong. So what we have done is we started using ARM64 for the compression and the indexing Lambda function, the second Lambda function, if you remember from the architecture diagram. So what it helped is it helped in improving the performance by reducing the compression time from 10 to 15%, and therefore eventually helping us cost 20% less because of a simple change in the configuration of the Lambda function. It is just a switch in the settings in the Lambda function console, if you guys want to take it out. Parallel processing of image compression plus indexing via SQS. Via SQS to Lambda triggers. So this helped us that whenever there are hundreds of images that are uploaded into the application, all of them are processed in parallel and available for with the compressed and an indexed image available as early as possible. Use S3 transfer acceleration for uploads from the dashboard. So as I told you, the original image that the organizers upload into our application is almost 15 MB, sometimes 20. We don't even know. We don't even have control over that. Now imagine uploading 20 MB images into 100. It's or into 500, right? It's such a network consuming activity, and it will slow down if you normally upload it directly to S3. So what we have done a bunch of optimization on that side. We use something called as S3 transfer acceleration, so, and multi-part upload also, which I think I probably might have missed adding here. So where what happens is uh, the image that you're trying to upload is broken down into smaller chunks, and all the smaller chunks are uploaded in parallel to S3, which helps in parallelly uploading the content to S3. And with acceleration, it helps even faster. Just to note here, transfer acceleration, again, if I'm not wrong, is extra cost. So you'll have to just keep a tab of that. And then the next one is setting up the S3 lifecycle policy, where, again, in terms of cost, what we did was, as I told you, the original image sizes are heavy, right? 15 MB. So what we have done, we have set up S3 lifecycle policy where all these original images, especially, are moved to a lower storage classes like infrequent access or glacier, depending on how long the image has been there. So these are a few optimizations we have done in terms of performance and cost savings as well. The next one is scalability and privacy. Scalability is very important for us because we don't. There will be hundreds of people who are using the application, hundreds and thousands, sometimes burst users as well. The first, and how did we solve it? The answer is serverless by design. So this is built entirely with serverless services like S3, Lambda, Rekognition, which scale automatically with no infra provisioning. So you don't have to worry about when there is traffic that is coming to the application. AWS will take care of scaling your application. Of course, there are some throttling limits. There are some limits at every service level that you may have to be aware of and build your application around it, or increase the limits by contacting AWS. Parallelism in image workflows, we already talked about it. Asynchronous and event driven. So we use SQS so that all the background heavy lifting of compression, because compression takes a little bit of time, it's not instant. And whatever we have done is a recursive compression where we keep on reducing or compressing the image as long as the image quality is not lost beyond a very acceptable value. So you want to, it's a time taking process, so we have made it asynchronous and event driven. This helps in ensuring resiliency and elasticity, as we already discussed. CloudFront edge caching, we just discussed, rendering all the images that the user is seeing from cache to improve performance and cost. And of course, the scalability, because they're all coming from cache. From a privacy aspect, it is very important, as I talked about in the very beginning of the call, right? We are dealing with user images, which is PII data, personally identifiable data. So we have to be very careful with this from GDPR compliance perspective and all of those. We have to be careful, right? So what we do is, first of all, recognition as a service. It doesn't store the face itself or the image itself. Rather, it stores the face ID, which is used for searching and recognition. Then what we have done is face collection isolation. So as you may know, KonfHub is an event ticketing platform. There are hundreds and thousands of events that are organized. So every event has its own collection, which we talked about, like a folder, so that there is no leak of images across collections, or one image from here is getting shown in another gallery and stuff like that. Then we use signed URLs for S3 access. Again, we talked about in the very beginning. IAM role isolation. Each Lambda function only has the scoped permissions. For example, recognition write access is only provided unless it is needed. The last segment of my presentation is the download challenge. Now, there is a reason that I wanted to talk about this, because this specifically was a bit challenging in terms of downloading. So I know I have not showed you this as a demo because this is still a work in progress. From our UI perspective, it is being worked upon right now. So what exactly this is basically a user, as you saw in the gallery app, want to download the images, right? As I told you, there could be hundreds and sometimes thousands of images as well. Now, a user will simply click on download. Some might want to download all the images that is available in the gallery. Now, we should be able to download that efficiently, reliably, and most important, serverlessly, right? So what are the various problems that we had? First of all, users want to download thousands of high resolution images, right? And each image, as I kept iterating, is in MBs, right? So large file sizes is basically, what does it mean? It's a risk of Lambda timeouts and memory limits. So Lambda, as I told, has a maximum timeout of 15 minutes. And let's say there are thousands of images and you want to download each of those images from S3, right? In one Lambda function, it might not be possible because it will take time to download them from S3, especially the high resolution heavy images. And one aspect is the time, the second aspect is the memory part. If you're trying to download it, there are two options. One is Lambda offers the ephemeral storage, which by default is 512 MB and can be increased up to 10 GB. That's an option, or you can attach an EFS to it to download, right? So these were the two options available with us. I'll talk about which option we took and why. And then a single large zip files are too slow, right? See, I am downloading all the images. I have to create a zip file and give it to the end user who requested for it. Now, having one zip file with such heavy, probably in GBs in size, is too much. It's very hard to manage, right? So that's another problem. And we wanted it to be serverless, scalable, and user friendly. So what did we do? So this is our serverless solution and the step function. So we use step functions. So the step function that you see on the right hand side is an actual step function that I exported from our AWS account. So what we do is we leverage step functions to orchestrate the entire workflow. As I told you, there are two limitations. One, the Lambda is timing out after 15 minutes. The second part is there's a memory limitation. And even though I can have 10 GB of ephemeral storage per Lambda function, I still didn't want to download a zip file that is of size 10 GB. Because again, it's a very heavy task for the end user also to be able to download that 10 GB file, right? So I didn't want to, or we didn't want to have that as an option. So what did we do? Is we batched the images with each batch containing 2 GB of 2 GB size equivalent of images. It can be 10 images or 100 images or 500 images. How many ever images that can be cumulatively for 2 GB, we got those, right? And I'll explain it here basically. So what we did was we first tried to understand how many images that the user wanted to download. Let's say, for example, there are 500 images that is of their interest. Now we identified what is the size of each of this image because we are storing that in the database. Okay, so we identified the size. Now what we did was, let's say there are 500, we batched them. What did we do was we reverse ordered in descending order all the heavy images on the start and the lighter images in the end in sorting manner, right? And what we did, we tried to pick the images or create batches rather until a batch is crossing 2 GB. Let's say first 10 images are touching the moment I loop through the images and the image size is crossing 2 GB, then that's a batch. Now from 11 to let's say 15, now we have hit to the 2 GB limit. So that is one batch. So like that, we started batching, okay, and we created the batches, not and stored those batches in S3, okay. And what we did is in step functions, there's a feature called as step function map. What does that map does is an S3 map state. So what does it do is basically step function loops through these batches that is stored in S3 and a Lambda function is called. That is what this download batch is. Okay, so for each batch, now I have identified the batches. I've stored the batches in S3. Now I have a loop, not in my application, not in the Lambda function, but the looping is happening in the step function. Okay, and the looping is happening on the batches that have been decided and stored in S3. Now, this map loops through each of the batch and passes the batch details to the Lambda function. The Lambda function downloads that batch and creates a zip file. So like this, it is looped through. So every Lambda function is trying to process images of up to 2 GB of memory size and creates a zip file. And this keeps on happening until the batches are done. Now, at the very end, what we do is we send an email to the participant, because this is a background activity, right? The user cannot wait. It sometimes can take a few minutes for us to be able to download all the images that the user is requesting for. So what we do is there's a zip file that is generated out of each map here. We consolidate all of those zips and send out an email with the link to each of the zip file, and the zip file is sitting in S3, right? So then what happens is the email is sent to the participant, and now they have an email with links, or rather, to the zip file that is containing all the images that they are requested to download for. So this is how we built completely serverless without increasing the complexity of our application. So the only thing that is slightly different that we did from other Lambda function is this Lambda function, the download batch. We increased the ephemeral storage from 512 MB to 2.5 GB. I know, although each batch is only processing 2 GB equivalent of images, we wanted to have a little bit of buffer. The 2.5 GB of memory ephemeral storage is provided, no AFS, nothing. And then it is available. It creates a zip file, and at the end of it, generates an email, right? So this is the way we solve the download case. As I told you, the problems were timeout, the memory. We wanted to make it serverless in nature, because a download is not something that is going to be very frequent, right? Someone is not going to, as much frequently as someone loading the gallery, is someone is not going to download the images. So we didn't want to have something very complex in terms of architecture. Maybe spin off a container, Fargate, or all those options were some things that we did consider, but we wanted to keep it very simple, because one is we wanted it to be easily maintainable, and from a cost perspective as well. So the final slide. So the key takeaways from this application, from this talk, if you have to, AI integration doesn't have to be complex, right? I know everybody is behind AI. Absolutely, yes. So am I. So is our application. But you can start with something small, and there are services available out there which can make something cooler, like whatever we talked about, with almost or zero ML and AI knowledge, because AWS is doing that for us. Serverless architectures allows you to scale effortlessly with no infrastructure management. We do not see a single server in the entire application that we talked about. Event-driven design is powerful for decoupling workflows and reacting to changes in real time. And why it matters is why serverless rather matters is faster development, lower cost, and better performance without sacrificing intelligence. Right. So with serverless, it's pay as you go. So you know how much you're paying depending on how much you're consuming. And the biggest advantage is you don't have to worry about the infra, because AWS is taking care of it. So you can focus on what is more important: building, solving problems for your users. You can build production grade smart systems with surprisingly few moving parts. As you saw the architecture diagram in the very beginning, it was nothing hard or nothing very difficult, but we were still be able to build a smart system with not too many moving pieces. There are moving pieces, but not too many. So yeah, moments captured, faces remembered, powered by AI, delivered by serverless. So that's pretty much it from my side. Thank you so much. This is Srushith Repakula. You can find me on LinkedIn, on X. You can reach out to me if you have any questions. I'll be more than happy to talk about serverless or anything AWS. So thank you so much for having me here, and it was a great presenting, and I hope you all got to learn something new.
Thank you for your wonderful session, Srushith. Seriously, even I have tried of similar thing for an S3 bucket, like an image search in a bucket, and now it's like whole new advanced level of how I can just extend these things. I really loved your session. So yeah, next, yeah. So next, we have Jones with us. He's also a serverless hero, and he's going to share with us like how the importance of having monitoring and observability for an application, but focused on serverless in today's note actually. So hi Jones, welcome.
Hi, Pupilan. Thank you for hosting this. Let me just get my screen up. There's always a tech glitch. Okay. Okay, I think I have to rejoin. Sorry about it.
Yeah, it's
One
fine.
moment.
Yeah.
Awesome. Okay, so thanks, Pupilan. Today, yeah, you did hear about Srushith sharing how serverless can help you power a lot of applications, be it complex or a simple one. I'll be talking about irrespective of those complex or simple applications, why observability matters. Because something goes wrong, what do you do? And this is something that I have from my personal experience. Of course, I'm not talking about it because it's one of the projects that I did in my previous organizations, but more from the experience and how observability really helps for your serverless applications. So, quick note about who I am. I am one of the DevRel engineers at New Relic. I'm AWS Serverless Hero. I also part of the AWS user group Bengaluru. I write a lot about serverless, be it on my blog and newsletter. I do a podcast around serverless, DevOps, observability, and also with respect to Kubernetes. So feel free to connect with me. And if you have any questions around the session, shoot me out on LinkedIn. Yes, today serverless is being well adapted. When I say well adapted, there are companies, there are enterprises that's really leveraging serverless for different kinds of workloads, be it with something that's happening asynchronously for their workloads that are powered either with Lambda functions for your function-based applications, or even things with respect to containers where you run it on Fargate, or even without running any infrastructure with respect to functions or containers. You could even have things as step functions, which Shushit was just mentioning. So irrespective of what your workload is, serverless could be the answer. And today, a lot of companies are adopting to serverless. So, like just a little meme from Simpsons, you could see an influx about everyone moving to serverless and adopting serverless in a wide spectrum for different kinds of workloads. Today, when you talk about serverless, it's not just Lambda function, it's not just Fargate, but it's a whole bunch of series, or a whole bunch of AWS services that enable you to work with applications in a very serverlessy way. When I say serverlessy, it's more about the cost that you don't have to pay for idle time, or you're just paying for what you're using. Also, in terms of you don't have to provision any infrastructure, you don't have to manage the infrastructure. You could keep your focus only on your business logic or your application, where you're using things such as Lambda function in combination with something like an S3 bucket, DynamoDB table. You have the API layers with API gateway or AppSync APIs. You could even have event-driven approach with EventBridge, SQS, SNS. These are just to name a few, but there are a whole bunch of AWS services that enable you to build serverless applications. Too many choices. Yes, I feel that too. I do get overwhelmed at times, like, oh, there's so many options. Which do I use? Where do I use? When do I use? But let's just consider a simple serverless pattern. Complex architecture, but simple pattern. So you could be having an application that does a bunch of things, where you have AppSync APIs, you do have things integrated into a SaaS event bus such as Stripe for your payments. You could have users who are uploading their images or PDF files, whatnot, into an S3 bucket, and you're processing all of them. And when you're doing these things, these could have event-driven approach where you're using things such as SQS, Event Bridge, and SNS, and a lot of Lambda functions, step functions. I've not included Fargate because this solution didn't really require a Fargate, but I do have a database with DynamoDB tables. I have DynamoDB streams, which are created whenever there's a read operation happening on the DynamoDB table. So in a nutshell, when you have things that are running around as event based, or whenever there's a request that's happening from the client side, when I say client side, it could be a web or a mobile application which the customers are using or users are using it, and making API calls into your backend where a Lambda function is invoked. From the Lambda function, you may have to read certain things from a database. You may have to call third-party systems with their HTTP APIs. You may have to do a bunch of processing by orchestrating using step functions, whatnot. The use case could be multiple, right? And when you're doing this, you may have built this, pushed it into production. People are using it. You as a developer or an engineer who has built this solution or built this application can go back on a Friday evening, have a good sleep, and suddenly what will happen is you may run into an issue, and in the middle of your sleep you may get an influx about having DMs, having PagerDuty, or things such as your uh, notification systems that's alerting you, telling that, hey, something went wrong, something went wrong, something went wrong. And waking up to such emails or such notifications at the middle of the night, not everyone would love it, but you may think, hey, what really went wrong? And you recognize or you identify that from my alert, some Lambda function is erroring up. And then you realize, oh, my simple architecture has a bunch of Lambda functions. Where do I dig into? Which part of the Lambda function do I look into? Because in a traditional serverless system where you have Lambda functions, you don't have one monolithic Lambda function that's sitting in doing all of the operations. Instead, you will have a bunch of Lambda functions doing specific tasks. And in those specific tasks, something could go wrong. When something goes wrong, you need to identify which Lambda function. And if your alert does that, then you are in a deep soup, because you first have to identify where did it go wrong, more than what went wrong. So back to the scenario again, where you think, okay, yeah, there is the Lambda function that's erroring up. So now I have to identify which Lambda function. It's humanly impossible for you to sit and debug into each of the Lambda function logs, going into CloudWatch or going to the respective X-ray traces, identifying, okay, this is exactly which Lambda function went wrong. But if you even give it a shot, try it out where manually you're trying to go into each of the Lambda function logs, identifying, okay, what went wrong, where did it go wrong, it'll take you a lot of time. And it's a lot of investment from all of your resources, where every engineer has to spend X amount of time looking into the logs, or even with filters on the logs, they have to look for the error logs and what caused these errors. Ultimately, what will happen is you'll start digging into different Lambda functions. You'll start digging into different Lambda functions where you could end up with things such as, okay, it could be this specific Lambda function that's erroring up. And you get into the logs, look for it, and then you realize, oh no, this wasn't the log. And then you see, okay, this where you try to identify where did this Lambda function get invoked from, because all of the Lambda functions are invoked with either an event or either things such as API gateways, which the user is invoking. So you realize in this scenario, it's the event bridge that's posting in events to your Lambda function. Then you look at event bridge. Unfortunately, you can't get into the logs of event bridge. Then you as a person who has built this application know that, okay, the event bridge is because I do have my DynamoDB stream configured with event bridge pipes that's going in and that's routing all of the events from my DynamoDB streams into a Lambda function. Then you see, okay, what could go wrong in a database, right? Like okay, I have my data. The DynamoDB stream sends in the change information in the event payload itself, telling in what's the new data that's been written into DynamoDB table, what was the existing DynamoDB table record. Again, what could go wrong in a database, right? So then you identify, okay, if the DynamoDB table has a write operation, be it an update, be it a new item that's been put, you look into which Lambda function was it that uh, that is making the DynamoDB put or DynamoDB update item API calls. Like literally, you would end up like the Scooby-Doo team, which is searching for clues, and you go hopping one from another Lambda function, from another Lambda function, and hopping on between different uh, AWS services, trying to understand which service caused this error. And then ultimately you realize that one Lambda function, which is writing into your DynamoDB table, was making the mistake of writing it with a different or with a format that's causing the error. Then you just wish that you had some system in place that could identify all of this thing is where did it go wrong, which Lambda function did it go wrong with, and a way where you could trace back, or a way where you could navigate the complete flow, identify things, and look at the errors, all of it in a very unified way. So again, thinking aloud, just going from logs and navigating from each AWS service, be it even Lambda functions, where you hop in from one Lambda function to another, it's really hard. And you just wish that you had enabled observability in place. Although you do have AWS giving you uh, log write permissions by default, but for tracing, you need to enable active tracing on your Lambda functions. So in case if you didn't know that, you'd have to do it explicitly. Before going into the topic around what's observability, why do you really need observability, there's a common misconception that people have that, hey, I do monitor, but what do you mean by observability? What do you mean I have to observe my Lambda functions? When you say that, yeah, we need to monitor it, it's about knowing when something is going wrong. Because as monitoring, you're actively looking at what went wrong, what went wrong, what went wrong. But when you talk about observability, it's about observing into the complete system and understanding, okay, something went wrong. Now I need to understand what went wrong? Why did it go wrong? What was the root cause of it? And observability helps you with it. So monitoring is nothing but knowing that something went wrong. And when you talk about observability, it's about knowing that understanding why something went wrong. Today, when you talk about serverless and observability, there are challenges with it, or monitoring. There are challenges with serverless. By now you would have understood that, yeah, there is, even with the simple architecture, there is too many components to a serverless application. For a simple thing, even with an API that does CRUD operations, you would have an API gateway, you would have a Lambda function, you would have a database, be it DynamoDB or RDS. When you look into these things, what really happens is that you have too many components, which increases the complexity for your applications to be monitored. When you're looking for what went wrong, you need to understand, okay, as a whole, what went wrong? Which part of your architecture caused the issue? And because there are too many components to it, what happens is there's a huge telemetry rush. When I say telemetry, it's the information or the details about the logs that you are generating from your application, the traces that it's creating, and also the events and metrics that are generated based on the execution of your application. So when a simple CRUD operation happens, you need metrics from your API gateway, you need logs from your Lambda function, you do need events also from your Lambda function, and of course, database related metrics and events. All of this, again, to tie it back, you need traces. And when I say you need all of these things, it's too much of an information for you to consume. And what really happens is that with the time, you lose a lot of time with it, identifying where did it go wrong, where do I even begin with identifying what went wrong. When you talk about observability, and I was just talking about this with respect to the telemetry, and the pillars of observability are logs, metrics, and traces, where logs is nothing but every action that you perform, you log it, you create a discrete message telling it what was this error or information or a debug log, where did this occur, which Lambda function did it occur with. So giving you all of the information about that instance of execution. A simple log from a Lambda function could look something like this, where you have the message available. This screenshot is from a step functions log, where you can see that there is the execution information from step functions, and also in terms of telling you what the message of that log is. Because this is instrumented with New Relic, you have a bunch of other information like entity and where is it coming in from. But all of these metadata gives you the information telling you, okay, which specific Lambda function, which specific execution was this, and what was the error message. Knowing that this was an error message that was just giving you an information about the step functions logs, you can identify, okay, this is good enough. But there could be times where you need information in terms of telling, hey, this was the error. Where do which Lambda function was this from? And that's where your investigation about what's the issue, what's the error begins. The second pillar of observability when you talk about is metrics. There are too many information that's aggregated and sent in to your observability tools. Even with CloudWatch, you could relate to it, where you can go into CloudWatch, look at the number of executions that the Lambda function has had. It could be metrics about how many cold starts your Lambda function is having, how many warm starts are there, how many times did you go over the concurrency limit. So all of these information gives you an aggregated metric about how the execution happened as a whole for a specific period of time. When you think about something as simple as an AWS SQS service or an Amazon SQS service for specific queues, you could even get in metrics about how many messages have been shared, what's the complete delayed messages that has happened, giving you information about, okay, how's the health of the specific queue. This is another metrics with respect to an SNS topic, where you do get in certain information about the publish size, the number of messages that's been published, the delivered message, and also the failed notifications. When you're talking about metrics and logs, of course gives you information about what went wrong. Metrics gives you how many times things could have gone wrong, but traces help you connect those dots. Traces are nothing but those pieces of information that's connected, ensuring you to keep the complete flow of the execution, where you can identify from one system from one service to another service, or be it from one Lambda function to another Lambda function. What was the trace? What was the invocation? And identify within the trace itself, get in the logs and the information for you to identify how is it performing. When you're looking at something where you have an SQS sending in messages into a Lambda function that's again writing into another SQS queue, or be it with patterns where different kinds of EDA patterns, what really happens is these are event driven, and you need to identify which was that event that's triggering and which was that destination where the event was being sent to. And traces really helps you with it. Here's a simple snapshot of a trace, where you can see the duration that each of these hops is having, where you can identify, okay, from one of the invocation, it's taking about 83 milliseconds, and there is also an SQS queue that's taking 79 milliseconds, and you can identify if there's a latency. Where did this latency happen? You could also identify information about, okay, what is the next steps that I would have to do with respect to this trace in terms of identifying how is my whole event flow or execution flow in my serverless application. Now, these are just about a few services, but when you look at Lambda function, of course, today, when most of them are building application, it's with serverless. It's Lambda function that's predominantly used, and Srushith was also talking about these aspects of Lambda function where you do have things and happening with Lambda function executions. You do, as a nature of Lambda function, it's ephemeral in nature, where something happens, it executes, and it forgets. It completes the complete Lambda function invocation. Once it's terminated, it's gone. You don't have a lot of visibility in terms of how the Lambda function is performing. It's not as simple as telling, okay, I do have my virtual machine, I'll SSH into it, get all of information. No, that's not possible because Lambda function internally is running on Firecracker containers, and you don't have visibility to it as customers for Lambda functions. And you can only see how your business application or your business code is working on Lambda function, but the internals of how Lambda function is working is very limited. Again, Lambda function and going with Lambda function as a design pattern with Lambda functions performing unique and specific tasks, it gets into a very distributed complexity because you come across multiple Lambda functions invoking each other. If you remember from that complex, simple architecture that I had, there are too many Lambda functions, and identifying which one is hard. And it's similar because in the production grade system, you have too many components, which adds to the complexity of it. Lambda functions and cold starts, it's something that you cannot forget. And you need to be well aware about cold starts. And these are certain metrics that is really important. When you talk about all of these challenges that could induce a lot of time for you to identify what went wrong, where did it go wrong, you do get in certain telemetry data. From all of these, Lambda function creates all of these telemetry data, and it could be generating in logs, metrics, and traces, all of them representing one of these challenges and how and when did they occur. Once you have this telemetry data, what's the next thing that you could do is, by default, it is being written into your CloudWatch. You could also enable X-ray for active tracing, which gives you the complete distributed tracing of your serverless applications. Once this is enabled and you have the telemetry data pushed into your serverless, into CloudWatch or X-ray, what really happens is that you need to go in to these services, identify what's happening, where which Lambda function log group was this, either navigate from the CloudWatch logs console or get a dump of it with CLIs, or even with respect to Lambda function console, you need to go to the Lambda functions, select the specific Lambda function, go into monitoring, navigate into the CloudWatch log groups to identify what the logs are. But these are not just the challenges. There are still many more challenges with Lambda functions. And to address them, you may need more information about, you have all of the telemetry data, but even with this telemetry data, there's a lot of gaps, because I was talking about how you need to go look into one Lambda function logs. It meant so many steps. So you have to look at, when you're looking at multiple such Lambda function logs, you have to keep switching each Lambda function to Lambda function. That context switching can make a lot of mess, because you at times you may think that, hey, this is a very time consuming thing, and look at one log of a Lambda function, then you could infer that, okay, nothing's really happening. But you can again switch into a Lambda function and see, okay, nothing's really happening. But at the end of the day, when you had to switch 10 different Lambda functions and go into each Lambda function, each log group, and for each time frame, that's a very time consuming and it's really a hard job for engineers to do. And also in terms of telling in, okay, there is a lot of information, but it's all fragmented. It's all distributed across uh, different log groups or different metrics and different insights from your Lambda function insights or Fargate container insights, uh, or even in terms of telling, okay, to identify how many cold starts happen, you need to have your own dashboards that's been set up. Also in terms of telling, okay, something went wrong, you have to set up your own alerting capability, alerts for the right errors or the right thresholds. You need to figure it out and set all of them up. Still, it is very hard, isn't it? This is this is exactly when you could use certain other tools where it could be third-party vendors, observability vendors such as New Relic, or you could even choose something as simple as OpenTelemetry. And along with OpenTelemetry, to support OpenTelemetry, there is also AWS distro for OpenTelemetry that follows the OpenTelemetry standards for all of your logs, metrics, and traces that could be exported to any of them. It could be exported to your CloudWatch or to a third-party observability tool such as New Relic. Let's Now that you have a fair understanding about, okay, how do I enable for my Lambda functions? How do I enable how do I enable the logs, metrics, traces? How do I export it into a third-party telemetry tool? You could do that by instrumenting the different Lambda layers that New Relic has, where basically it's an extension that's available. With extensions, there are certain environment variables that you have to configure and add the Lambda layer to your specific Lambda function, make those configurations, and the extension will take care about sending in data into New Relic. A simple example is one of the CDK applications that I have, where you have to configure in certain credentials, certain environment variables, different configurations for your Lambda functions, such as your handler, and enabling active tracing by setting tracing to active, and also making the right decision about your memory and timeout for your Lambda functions execution. Once you have the Lambda function set, when they're being executed, you can see the telemetry information from Lambda function. That's giving you the complete details about how they are performing, be it in terms of the number of timeouts that have happened, the cold starts that had occurred during the different executions, the duration of each of the Lambda function execution as well. This is just a summary of information, but when you want to dig deep, you can look into the traces because tracing is enabled. There's also logs that you get in from the Lambda function, and you can look into all of those logs. Now that if you notice something from the previous screenshot or the previous GIF that I had, it did mention where did this Lambda function get invoked from, and you could see that it was from an API gateway endpoint, and you could look into API gateway information as well. The number of triggers it had, what was the invocation duration, and also if there was an error, when was the error, and you can start digging deep if there was an error. Well, it's all distributed, right? And I was talking about traces, and every time you're looking at traces, it's moving from one entity to another entity, one Lambda function to another Lambda function, and you just end up being like Homer, just rotating around the place. If there are errors, and especially with traces, you could identify these errors, and you can look at the error traces from those Lambda function itself. And one of the execution where I was doing with a specific Lambda function, this had a missing user ID, and I had the error message written as missing user ID from my Lambda function, and that was able to export whenever there was an error. It was able to export the complete error message along with the name of the function, the message that it had, and also telling you the request ID, the trace ID, making the third-party observability tools such as New Relic stitch all of it together and giving you a contextual information for the specific trace. When something goes wrong with Lambda function, you need to look at the traces. And this is one such example where you have the information for error information for the trace for the specific Lambda function. You could see that it's from an API gateway endpoint, the invocation breakdown, and also telling you what the logs are. If there's any custom event that's invoking, you will also get those information. With distributed tracing, I was talking about active tracing with Lambda functions, and when you're enabled active tracing, you could see that there are different traces that's being created, and whenever there's an API invocation. So this is a Lambda function that's invoking DynamoDB and getting certain details. So there's a query that's happening into DynamoDB. You can identify from this that, okay, the Lambda function execution happened, and the next step was, okay, how long did my DynamoDB query take? So you can see that it took 23 milliseconds for the DynamoDB query to be executed and return back the response. Talking about cold starts. Cold starts is something that's very important for you to identify and know that, okay, if something's going wrong because of cold start, you need to address it. Be it in terms of making optimization to your Lambda function itself, choosing the right runtime for your Lambda function, and also in terms of reducing certain things such as fat layers or whatnot. So to identify Lambda function cold starts, you can also take a look at the latency that each of the execution has. These are two such executions that we went through for a specific Lambda function itself, where one is a cold start, one is a warm start. You could see that when there is a cold start, Lambda function itself took a huge amount of time, close to about 30 milliseconds more than the regular warm start Lambda functions. So these are certain information that you could derive out using certain observability tools. When you talk about Lambda function and using DynamoDB tables and getting data from DynamoDB tables, you need to understand how your database or DynamoDB is also performing. If there are any throttling requests that's been done, read-write throttles that has been occurred, or is it well under your write capacity or read capacity that you have configured. So to understand all of these things, these are certain metrics that you get from DynamoDB table. Now that you understood a little about monitoring serverless applications, and I did refer to New Relic for enabling you with all the logs, metrics, and traces. How does New Relic help, right? It could be a unified way where you are getting in data from Lambda functions, getting in data, have a unified way, look into certain logs or metrics, an easier way to instrument them as well. Now, I have a CDK application that's been configured, and let me just go and make some invocations to my Lambda function so that we can see that different executions as well. Okay. So this is one such Lambda function where I'm adding things into my cart, and where I'm just invoking certain APIs using curl. Okay, now that I would have to navigate into monitoring, and you could see that one such occurrence of the API curl execution that I did was success. These are certain metrics that Lambda function itself exposes. When I was talking about, okay, how do you understand the execution of Lambda functions and how these are being executed, you need to look at different metrics that CloudWatch gives you, different logs that are available either on CloudWatch, or get even more better insights with Lambda Insights. And these are just observability ways where you're understanding the execution of your Lambda function. It could also be in terms of, okay, I'll look into the execution of this Lambda function. And there are a couple of executions. You could see that there are a whole bunch of logs generated from my extension, because this is also uh, writing into my or this has been exporting the telemetry data into New Relic. So you could see the Lambda extensions making certain log entries as well. But overall, if you just see, the specific Lambda function execution was successful. It completed the complete execution in about 500 milliseconds, and the rest of the information about the billing. There's also active tracing that's enabled, so I have the tracing ID, and I can even switch back to my uh, New Relic dashboard where this has already been instrumented, and I can look at this. Let me just change the time range into 60s, 30 minutes. Okay. Okay, looks like some error with the time range, but this is from one of the examples that I previously ran, where I could get the complete information of this Lambda function itself with the metrics exposed by Lambda function, and this is being instrumented using the Lambda layer that I was talking about, and also with the CloudWatch metrics that's been integrated into my New Relic account, which is getting me all the telemetry data, telling it what's the duration, if there was a cold start, the number of cold start rates, the error rates that had occurred, and the number of invocations, the maximum number of memory that's being used for the different executions of your Lambda function. Not just these, I was talking about this being New Relic being one of the unified ways of getting in your telemetry data. So this is just my Lambda function entity. I can go into my logs, which will derive all the logs for this specific Lambda function. The same thing that we saw on CloudWatch, and also with respect to telling in the different invocations and metrics that the Lambda function has. This is similar to what you saw at the summary page, but the additional metric is the concurrency executions. And not just these, now that the telemetry data is there, you could build an advanced capabilities with the observability tools or with CloudWatch, where you could define your own alerts, you could define your own dashboards, giving in the information that you really want to look at and monitor and observe what's really happening. Well, all of this data, yes, you have it, but it still doesn't feel right? Because once you have the data, it is also important for you to follow certain best practices or ways where you can identify what's happening. You could also send in certain attributes. You could send in certain information into your logs, adding in the metadata and giving you the right information about where was this log from. That helps you with your complete investigation about what went wrong and identify which was the place this happened and what caused it. Also, choosing the right metrics. I mean, telemetry information about all the metrics is good, but you don't really need all the information. So you may have to create the right dashboards for your right metrics that you want to look at and understand how it's performing. Also, with alerts, you need to configure the right context so that whenever you're getting an alert, say for example at 2 a.m. you're getting an alert telling something went wrong, you need to know which Lambda function or what was that error that happened in that Lambda function. Be it even a simple alert that is giving you something that went out of the concurrency limit. Yes, you need to know which Lambda function. So giving in the right context for you to identify what went wrong and where did it go wrong. And with this, I conclude my session about why do you really need observability with serverless and how New Relic is one of those observability tools helping you achieve it. So thank you for joining in and learning about observability with serverless.
Thank you, Jones, for sharing your insights on why observability and monitoring is really important for any application. Uh, Going forward, I have Avinash with us, also Shrushith. So Avinash is also a community builder. So today he is going to be following it's like an Q&A session kind of a thing with the two sessions which we had earlier, plus with general serverless discussions on like the best practices or some design patterns kind of a thing. So Avinash, welcome.
Hey, thanks, Popular. And it was a really good, insightful talks by both of the serverless hero. Like Sushil has mentioned about how he built AI powered serverless photo gallery, and Jones was talking about why observability matters so much, right? But we'll little bit extend these discussions more in terms of the way the Boban has explained it, but little bit we'll go little step deeper into that. Like it's not just about tech, right? Because I wanted to touch on the point about how we can make a decision, what's the thought process behind the specific skeleton or tech stack which we use, right? So that people can take inspiration from them and can build something amazing like the way they have built, and the way can have a better observability for our application. So not to spend more time on, let's dive into that. So let me just quickly grab something. Okay, so I'll start with the first with Sushit. Sushit was having the first session, so I would like to start with Sushit one. So your talk was described about like the AI photo booth, right? Like kind of things, which was purely was event driven, which you talk about the step function, the diagram which you talk about was complex, not easy to hard also, but like that. But let's take a step back on that, right? On So my question is around what exact problem where you are more obsessed with solving this, like what was there a specific pain point, or you can say that what sparked your curiosity to try this architecture.
Okay. As I told in my session, the first thing is I have no clue how AI works, or I have no context on ML. But the requirement was to build an AI gallery app, right? So, uh, I mean, when the requirement comes, you somehow end up learning, understanding. You still have to do it. You cannot go back saying that, no, I don't know. So, in all honesty, probably that was the spark. So we explored what is the easiest way for us to get started and build the application that we wanted. And we saw that recognition was actually it has been there for quite some time. In fact, even before all of this AI boom of ChatGPT, LLMs, and everything that came into picture, right? So it has been there from before that, and we thought when something is available already, there's no need for us to start from scratch, right? You consume the service, you get your work done, and just move on with whatever is the next thing that you will have to do. In certain cases, not always this would work or this is suggested. So in our case, we wanted to get something up and running very fast because there was an organizer who was really looking forward to it, and they wanted an application. So something very fast, going to market, serverless, that is what it provides. Something that's cheap because we are only charged for how much we consume, and the ability to consume the services that is already available without having to understand too much about AI and ML. In this particular case, we went with recognition. That's the whole story behind it.
Okay, good. I think you have highlighted the one word called fast. I will come back on that word later, because that's how the why people choose serverless, right? So that can be more bulleted, that fast word. Well, we'll be back to on that. My next question on that, I think, like it is not to still you have a serverless hero, and that's why you use a 100% serverless one. But when you evaluating any architecture or any service, AWS services, right, how do you decide between something serverless or virtual server? Like being a developer, I don't have any kind of thing, like I always go for whichever is good for, like same way you also, like you're the developer, son of the developer, right? So between the serverless, what is a container, or a traditional approach like just launching the EC2 machine, right? How do we decide? What's the thought process behind it when you choose the architecture?
Okay. So in our case, at least, we take into multiple things into consideration. As we all know, there's one size doesn't fit all, right? And the same thing goes with serverless. It doesn't mean that because I'm a serverless hero, I endorse it. It doesn't mean that it's the go-to solution for everything, right? There will be certain cases, scenarios where serverless probably is not your go-to answer. It may work, but it can end up with probably more cost or difficult in terms of management, because as Jones mentioned, it's a haywire, especially when it's a big application. You have too many Lambda functions, too many services talking to each other. So it's not something that we go. We as in our company and we go because we are in favor of it. So a few things that we take into consideration. The first thing, which a lot of people do not take into consideration when we discuss, but in actual they do it into consideration, is the talent that they have in the company, right? Do you have someone who's able to actually go the other way around and do things for you? It's equally debatable on the other side also, right? Someone who's traditional, will they be able to pick up what is there on serverless, right? So we as a startup, what we do is all of us are still completely serverless. So everybody in our organization is very much aware of how things work in the serverless world. So that is one of the primary factors. Then comes the go to market, as I told you, right? As a startup, it's very, very important for us to go to market. We will see what happens after it goes. Let's first test out our idea. If it fails or through, that is the most important part, right? So with serverless, it gives us the velocity, right? Now we, of course, evaluate. Sometimes, if I have to give you an example, when I was working for on another project where we had to have a continuous communication between the backend and the UI for a specific scenario, and we kind of evaluated and found out that yes, we can achieve this with serverless, absolutely possible, but it would end up with a lot more cost because the application would have to ping the backend for it to be alive and contextually answer some things, right? So it meant that Lambda had to be alive or it had to be pinged way too frequently. So in such cases, what we do is we analyzed and we thought, yes, serverless fits here, but in terms of cost factor and in terms of the complexity it was bringing into the application, we thought this is not probably the right answer. So we then switched over to an EC2 instance. We spun up something and then we tried out, and we were able to achieve whatever we wanted with probably lesser cost. So that is another factor. Go to market, and at the same time, whether it fits the bill in terms of performance and cost. So these are a few things that we constantly take into consideration, not just between serverless containers or traditional EC2 virtual machines. I mean, as Jones already mentioned, within serverless there are just too many options, right?
Yeah.
You want to go with SQS, SMS, Event Bridge. What is it that you want
Yeah.
to do? So we do ask these questions every time we get into it. Pricing factor, right? Even within serverless, some services are probably costlier, some are cheaper. Uh, some things integrate better with some things. So all these things are taken into consideration while building. Although we are all fans of serverless, but end of the day, the solution. I mean, we are all focusing on a solution to the problem. We should not focus on the way of solving the problem.
Yes, yes, absolutely, absolutely. That's the right approach. I think like if you focus on the more on the that part and what is needed to be there and how it can be easily done, that can just really focus on like the good insight on that part. With the same line on the question on that, since you mentioned that right about the cost part. So one thing, the who are building the application using the serverless as well, it will be to sometimes worry about the hidden cost also. When I say hidden cost, like example, Lambda has 1 million requests free, but along with that, there's a tag as like based on the execution time and the RAM what we use also, right?
Yeah.
So these kind of hidden, but not in highlighted way, and not everyone also like when you're getting the bill, it getting realize okay, there's something is coming out when you reach from the 1 million more than that, or you shoot up something, and that's it, you mentioned, right? So in your example also, you had mentioned about image processing. There are many complexity was there. How do you evaluate the cost versus performance in an experiment like this experiment? Like
All right. What I would say is, I mean, I would like to start the answer with saying that there's no free lunch anywhere in the world, right? So everywhere there is cost. AWS is not
Yes.
doing anything for free. Right?
Correct.
So
Yeah.
irrespective of the service that you're trying to consume, serverless or otherwise, there will be costs. And as a developer, or more so as an architect, it is very important to understand the various components of your architecture and go through one the pricing. And this is something thumb rule that we follow. One is the pricing, the second one is the throttling limits, right? As I told during my presentation as well, with serverless we say that yes, it can scale, it can scale, it can scale, but all of that has a cap. Every service has a throttling limit. And a lot of times in my earlier days, when something would hit, we were like, okay, I thought serverless would scale. Now I'm getting throttling exceptions. What is happening? So the same thing goes with pricing. So anything that you look or bring into your application, you first have to estimate, understand, predict, and then try out, and at the last part, monitor. Right? So this is what we generally do. Start with estimation. Any component that you bring into your application, make sure you understand the not just from the feature perspective, but from its pricing and scalability factors, so that it doesn't become a bottleneck in your application in terms of performance, and in terms of pricing, it doesn't eat your bills, eat your pockets with a lot of pricing, right? Let's say, for example, Lambda. So a few things that we take into consideration, which is very common, is you right size the memory. Right, there's a AWS Lambda Power Tuning application that is available. You basically run your Lambda function code with different memory sizes to identify which is the most performant, which is the most cost effective, and then the sweet spot that helps in both. This is something that we constantly keep doing across our applications to make sure that it is not always only about increased pricing, right? Because I have seen a lot of times people over provision. Like, if I am
Yeah.
not wrong, serverless framework back in the day used to have 1 GB as the default memory. A lot of applications would not need 1 GB for sure, right? So it is very important to identify, understand such kinds of aspects, and you can only do that one by reading and analyzing and estimating it beforehand, and then you make sure that you don't stop there. You have to constantly keep monitoring, right? This is again one thing that I have read and I believe in, is a lot of companies do not actually expose the billing section to the developers, right? I mean, most people don't even have production actions, which is absolutely fine. That is absolutely needed as well. But as a developer, from the very beginning, everybody should have access to the billing section so that they know what is the application that they are building, how much is it costing. So this has to be a part of the entire life cycle policy of the development, so that from the developer mindset itself, it begins saying that, there's something that is probably costing a little too much. Should I start looking at alternatives, or should I start looking at optimizing and stuff like that? Especially for someone coming from a startup where money is the most important thing. this, this is this
Absolutely.
is something that we constantly do.
I still remember like one of the product company where we had everything was there, FinOps was there. So we used to get the mail after 6 7 months only when FinOps spent like, okay, your bill is there now you optimize it. I used to raise them concern like why can't you give the options at least to see the bills? So we optimize in early stage only,
Yeah,
but there is a lot of policy and everything was there. So
yeah,
obviously, and I wish we can have some kind of feature. I think I have given this feedback to the product team also, AWS product team about when we deployed anything, right? So how can we know some kind of estimated price? We do have a cost calculator, but
Mhm.
cost calculator is something different. When I
Yeah,
write the YML file or when I create something, right, can I know a predictable cost upfront itself? How much is going to be cost me, kind of things, right? That can be give me a better idea. I was
Mhm.
doing the current startup itself, like doing some cost budgeting and everything part, but could not project it. So I had to do
Mhm.
some calculation, use the chat GPT, put up some formula. Okay, this much request I'm projecting, and every day this much price will be there. But still, is the like how work for it. Maybe
Yeah,
AWS might do something better in terms of cost, so that developer can get more power to choosing the right services based on the this part.
yeah, yeah.
I think one more question to you is like where is that moment in your project, like you have been working with the concept for a long time, right, where initial idea didn't work out, but due to the curiosity you landed with the better price, better path, right? I have been hearing from you long time, you use many times the state function, everything state function always curiosity create, right? But why was you landed to state function? It was the first initially you heard and you tried or something, or something didn't work out but you wanted to do something better and you come up with a state function.
Okay. Yeah, I think since you talked about step function, I'll take the same example. In a few of my presentations in the past, also, I have mentioned this. So we built an application that is completely about payments, right? So we did not go with step functions. We had everything in code. And it was so messed up, so messed up. When the developer came to me for the review of the entire code, not architecture, because there was no architecture. He wrote everything in the code. And I was reviewing it, and it took me a few days for me to wrap around my head of what is happening. It was so very complex that I keep giving this example when especially talking about step functions, right? So we had to look through hundreds of events, and error handling was such a pain. Um, when you have so much of data to loop through, compute in your application, it can become challenging, not just from a coding perspective. See, for me, coding is probably the easiest part. Maintaining, debugging is the and probably enhancement in the future is the tougher part, right? As we all know, we can all code very aram se, but if you say, okay, go back and touch this legacy code. When I say legacy, few months, not years, right? Few months, which is a code that I only wrote. It will be complex. I would not even remember what happened, right? So in this specific example, without even going to dev environment, it's not like, okay, we did something, we went to production, it failed, it was horrible, we went back and refactored. We identified it at that very moment that this is too complex for a single lambda function to be doing all of this. And then we started looking at options, and step function was the solution where we were very much easily be able to orchestrate, and it made things so much more simpler. Right now, the immediate question we have to ask ourselves is, we're bringing step functions. Step functions is not exactly very cheap, right? It has its own pricing. Now you're bringing another component into your architecture. That means two things. One is you are going to be charging extra because you're consuming something extra from AWS, which you probably are able to do it within your code itself, right? And the second part is someone has to learn, understand how step functions work, because on a little bit of learning curve, you have to write a YAML or a JSON file. You have to understand what's the state. You have to understand various features. It has a bit of a learning curve of itself, right? Now you kind of weigh in both the options. What is the trade-off, right? So is extra learning curve plus a little bit of extra cost versus having a little more messy, complex code, which is probably a little too difficult to debug and maintain. And then we said, no, it is very important for us to have something that is neat, clean, and performing bug free. So we will take the approach of going with step functions, even though it is increasing our cost slightly and is increasing the deliverability times. Right? We talked about making sure that you go to market as early as possible. But in this specific example, we actually slowed down to make sure that our application is more stable. So, as an architect or as an engineer, it is very important to always constantly keep looking at these trade offs and see what is the best, not at that very moment, but keeping the future in mind and future developers in mind.
Yeah, absolutely right. I think, and debugging the messy code and long legacy code is always be a difficult part even to that journey. I think with this, let's move our needle to the Jones here, because we are just talking about debugging, right? So the Jones has just talked about, like, which I had enabled the monitoring earlier, and I feel so like, being a parent of a kid also, I feel the observability will be nothing but like raising the kids only. You have to be observed from the day one. You cannot have excuses. Okay, I will do, like, look into later. If you ignore it, you will miss it out on your thing. Same way with the application development, and Jones has already mentioned about that. Let give some more insight on that part, right? So So serverless is often pitched as a handoff. Okay, sometimes like for the builder, something like real world, sometimes messy because when you have simpler, I remember in one of the fintech startup I used it. We started with a 10 Lambda, and later a 10 Lambda became a 500 Lambda with because the microservices pattern and everything. And later it's become more chaos to the monitoring part because more you scale it, you more have a number of Lambdas and everything. It become a things part like. So what a blind spot do you see in terms of which might not release when we first move to the serverless? Like what do you want to suggest it in there?
Yeah, I think I called out while I was presenting as well, right? Serverless gives you a lot of complexity. It's hard for you to know, okay, you when you say 500 Lambda functions and identifying that one error within that 500 Lambda functions is the pain point. Blind spots there, that's one reason why you have observability tools, which can give you that visibility, give you that alerting capabilities, the dashboards that are there, easier way for you to identify where is it going wrong, right? Blind spots, when you want me to explicitly call about blind spots, it's those executions where, again, Lambda function is execute and forget, right? It executes and you need to identify, okay, there are certain invocations, that's happening in the background, and also there are there are multiple just concurrent executions that's happening, right? So most of the times it could just be concurrency errors, or it could be timeout errors that's causing the Lambda function to be interrupted. And you don't have that visibility telling that, okay, for this specific execution I need 3 seconds of timeout, I need that 30 seconds of timeout. You don't have that visibility. You need that. I know there are tools today, power tuning, which Srushith mentioned. It gives you those configuration information, but most of the times there could be scenarios where your Lambda function is calling 100 different APIs, or making invocations to different AWS SDKs, which is taking time and which can induce a lot of latency. When again latency is there and it's going overboard of your timeouts, it errors out. But you don't have that visibility telling that, okay, because this one service, this one API is taking more than your timeout, this is the main cause for your Lambda function timeouts, right? That visibility or that blind spot still exists. But yeah, of course, you do get information telling that, okay, this was the last invocation that happened, and this timed out at this specific millisecond. But until when is still a big question mark.
Yeah, makes sense. Okay. Like, so do you have any story to share with us? Like, because I remember, I realize, right, like always, I used to wake up in a midnight, get you talk about a pager duty, right? So we used to have Obgini calls, and I used to get the calls on my mobile when somebody is not picking up, and then hop on to the production support call. So do you also have a similar kind of story where you dig deeper into the saving your application by have to detail out into the your data insight to the observability platform like
Yeah, at least the 2 a.m. Wake up calls was in the days when I was not using serverless. So I started off with PHP and the traditional way of running things on EC2 machines. A lot of times it was the ALBs that were erroring. This was with a startup, and the customers of that startup were based in Europe. So it was usually at my late nights that there was a high peak of traffic coming in, and a lot of times ALBs were misconfigured and there were errors with it. And I mean, you start adding in different kinds of alerting capabilities where you do get in that alert at 2 a.m. But at the middle of the night, like, let's talk about it with all honesty, right? At the middle of the night, you get an error message telling in, okay, this went wrong, and you're in no mood to see, okay, what really went wrong. You're frustrated at that point. So it started off there, and I guess that's exactly the moment when I realized observability is important. Although I didn't go overly mature with observability at that point, But over the years, yes, with serverless, there was a time when we were using AppSync, and AppSync has something called as subscriptions. Apparently, we were not aware that there was a maximum subscription limit on AppSync. And I can see the nod that Srushith has. So, yeah, most of the times this was a mobile application that's being used, and subscriptions were used behind the scenes, and we used to hit those errors. It was always a problem for us to figure out different kinds of workarounds, going with something such as IoT Core. At the end of the day, making the decision to go with IoT Core rather than AppSync when you want to scale and things be more robust in nature, right? So yeah, there are times when errors have woken me up. There are times that has caused my sleep, the precious sleep, right? uh, yeah.
Okay, so I being into the serverless hero plus the observability expert on that part, right? What advice you can give it to the any startups founder or startup engineer uh, if they are building using a serverless application today? What's the minimum observability investment you can recommend? I think we were discussing last week about the same thing, right? How much we can save or get some kind of free matrices from the New Relic or another tab platform, right? What is the recommendation thing which can have a minimum setup for all this? Because I will say, yeah, okay, yes, we want from day one availability, but with some concern budget also, what is the best thing we can recommend it to do it?
Yeah, observability is something that you need from day one. Like, there's always a saying that I used to say that you need infrastructure as code from day one. You need observability from day one. Uh, there is an additional cost. There are times when you feel, okay, uh, this observability tool or the cost that you are incurring because you're implementing observability practices is heavy on your AWS bills or the overall bills that you incur. But if you take a look at it, right, you don't really need all the telemetry information. 99% of the times it's the good things that's happening and you don't really look at them always. So there are ways where you can set up certain filters, drop filters, be it with logs or even with retention policies that you can set, telling in, okay, uh, if it is a 200 log, I don't want to log it, just drop it. If it is a 400 or 500 error, log those, because that is important to me. If you could have retention policies setting in, telling that, okay, after 7 days delete all my logs, or take a dump of my logs, put it in S3, put it in archive. So there are certain cost optimizations that you could do even with observability, so that you're focusing more on what you really need and ignoring the things that is always there. uh, there are times when you just have a log that's sitting in for over hundreds of days, and multitudes of logs that is 200, which is really a dead investment. But uh, it is really a very good investment when you're looking at when you're looking at error logs or the error metrics. So the choice of investment is really needed, but what are you using it for, or how are you storing your data, or what are you ingesting with your data in, that really adds on to making it a more cost optimized approach.
Yes, I think this sounds good because I'm also going to try it out something similar approach only with a less things like as you mentioned, right? You can filter out a 200 one because developers generally always keep console logs or some print log will be there even if something is there, and that can also cause the storage for the logging part. So by following just simple best practice can save a lot of cost and have the first day itself play the observability platform it upon running it. Now we can have a little bit more few questions around both of you directly. You both can choose on which who will go answer on that. Like you both work on a multiple different like you work on a different company, he work on KonfHub and multiple application KonfHub has built so far and it's working well and scaling tremendously, right? How do you how do you decide like what piece of advice you uh, like what piece you build yourself versus the managed service, right? So how can I tell you, like, the question if I want to frame it a very simple way, what does the curiosity lead you to go into dig deeper rather than just writing the service together? So this kind of recommendation or maybe this insight can help us to developer who wanted to start with serverless or something like that. What exactly spark you to go into deeper?
I believe there are multiple parts to this question itself, right? Like the first being the curiosity piece, where even though it's a managed service, right? Like say for example, Lambda function. When I'm using it day in day out, I would need to know like the internals of Lambda function. Of course, I don't have the source code access to Lambda function, but I need to understand how it works for me to. See, it's over a period of time with experience you understand these things, but even as a developer who's starting off fresh, you need that curiosity where you need to understand how the system first works. It's managed. You're not worried about the infrastructure itself, but you need to know how that infrastructure works, right? Because say for example, I was talking about PHP days, right? If I take the same PHP code, put it on my Lambda function, even without knowing that PHP is not supported, first of all, and also it's a huge, crazy code base. Putting it on Lambda function, the size limit is there, so you need to be aware about the limitations, the quotas that Lambda function has. There are soft limits, hard limits, right? You need to be you need to have that awareness, and you have to be very mindful of it. Even today, a lot of people use monolith lambdas, right? Why do you use it? I mean, they will have a very valid answer to it, telling that yeah, I need it for XYZ reasons. But really, if you look at it, lambda functions are meant to execute once when there's a request that's coming in, serve that purpose for that request. If there are multiple things that it has to be done, you have to break it down eventually. Srushith talked about step functions. Step functions came into existence to orchestrate those kind of needs, right? Where you have multiple pieces for your request, executing them. So you have to be aware about what are these limitations. Not just that, you have to be aware that what are the alternatives also. So step functions is an alternative for using monolithic lambdas. So you need to be aware about these kind of insights about your architecture. Shushit,
Yeah, I
what
think
are it?
I think I feel I know that like people we generally give the developer the in one thought is about think about the fail first approach. The same way also when we doing anything right, we should think about the limit, know your limit first approach also. Because if we know the limit of specific into that, then only we know that okay something how much we can leverage and how much can't we do it. Yeah, I think sorry to break. Do you want to add anything?
Yeah, I think Jones covered it pretty much. Curiosity, I think, is the first one where if we are building something and you're consuming something, as a developer, you are more curious to understand what is there inside. Because see, there will be sometimes cases where you start with managed services, but the moment you start growing and you have different use cases, whatever you're consuming is probably not solving your problem, or it's not sufficient anymore. It probably solved you, but it's not sufficient anymore. You have outgrown, or your application has outgrown the solution provided by the managed service. In such scenarios, you should have the technical capability to understand what it was doing, so that I know what are the various other alternatives that I can look at, so that I can replace this with that, right? Or maybe build on my own, go back to the bare metal, build it all myself. So curiosity is very important, and you never know when you may have to replace it, or worst, when AWS will kill it. So it is very important to understand what and how, so that you are prepared for situations like this. So yeah, although it doesn't happen often, AWS killing anything, but you always have to be prepared for the worst.
Yeah, yeah,
Replication
it makes
planning.
sense. Like, correct. Even if serverless remove the headache of a developer, still the curiosity has to be alive to know better and the leveraged in a better way only. That's a good piece of advice we can give it to the audience from this one. I think the one last question to you, both of you. So, if you were to give one piece of advice to our curious product builder or developer want to build reliable, innovative solutions, what could be? In simple term, I can say that a very trendy word like, okay, what is the checklist or maybe the list of questions to be checked before choosing anything or before going into that?
Okay. Uh, Checklist wise, I mean, uh, this is irrespective of telling serverless or the traditional approach or containers, whatnot. But whenever you're choosing any specific tech or any specific tech stack, one is you need to understand, okay, am I capable enough to understand these internals about what it is, given the timelines? Also, you need to be mindful of, okay, there is a learning curve involved. How how well can I adjust to this learning curve? Because a lot of times, right, you may think, okay, AI is the trend today, and a lot of people are force fitting AI into their solutions. But is it really required? I mean, there's a lot of learning curve as well when you talk about AI, because you need to understand how the LLM models work, how different compute for these LLM models work. Of course, today it's all API based, but no one really worries about these things. But you need to be aware about the internals of these technologies. Uh, the other thing that I would always recommend to folks is don't go with what's trending, because it's a wave. And I know a few years ago, serverless was the wave, and everyone was telling serverless left, right, and center. Today, it's the thing with AI. Tomorrow, you don't know what is that next thing. So don't just go with trends, go with something that you are passionate about and that's really helping you solve problems. Because on a very longer run, these are these insights or these knowledge about these tech stacks will help you build on or grasp on things that's happening in the trendy world.
Yeah, I
Yeah.
mean, adding to what Jones said, uh, I mean, going back to whatever I said, right? So there's no one size fit all, right? So don't have affinity towards a particular thing just because everybody is using it, or just because that's the trending service or trending technology right now. I think at the core, one has to keep reminding themselves what is our job to solve problems, right? And what is the best way we can do it in terms of performance, scalability, security, and pricing, right? So if you ask me, these are the 4 or 5 things that I would keep in mind while building a solution, because at the end of the day, the application is greater than the technology that it is built for using. So keep that application in mind. Don't run behind a particular service. Always make sure whatever you're building, you understand what is happening. You understand, not only understand what is happening or what it can do, but understand what it cannot do, or rather what are its limitations. So that because as they say, right, you're only as strong as your weakest link. So you need to understand what are the limitations to be able to counter that, or build around it, or the worst, be aware of it.
Yeah, that's a really good piece of advice both of you given, and thanks for bringing those insight. I think hopefully audience will also get some insight from this discussions. And thanks, Popular, for giving the opportunity to have a like detailed depth discussion about not purely technical, but kind of okay how somebody can build, what's the thought process behind choosing specific things. Like, over to you, Popular.
Uh, Perfect. Thank you guys. You are right on time, and thank you, Srushith, for the session really how we can use serverless in our day-to-day applications, and how we can build quick, effective applications which go to market in very less time with very less complex setup. And Jones' session on why the need of observability and monitoring is important right now, and how it can save the developers being debugging, when the time on spent on debugging, and understanding more on where it goes wrong and how to find it and solve it effectively. And Avinash being the
representative of the audience asking about the experiences of Jones and Srushith, like how did they adopt serverless and what are the difficulties that they faced during their journey, and also sharing some of his insights on the problems that he did face and how did he overcome. And thank you for that. And I really enjoyed the session, and thank you guys for spending this time. And yeah, thanks.
Yeah, thank you so much for having us. Bye bye.
Thank you.
Thank you all.
Bye.
Bye-bye.